without further ado, we'll go ahead and get started. Good afternoon again, and I'm Mike Warlick, Vice President for Defense at AFCEA International, and I'm glad to see the crowd growing this afternoon. It's been a privilege to help facilitate the Coalition Interoperability Forum. It's been a good experience for everybody who's attended, I'm sure. Once our speaker's done, she'll let you know when she's ready for questions, and then you can ask them then. So, without further ado, our speaker this afternoon is Dr. Maurice Pino. Dr. Pino is a principal cybersecurity engineer at MITRE Corporation. Within this role, she works within a multitude of MITRE federal sponsors, including DoD and the international community in the area of cloud security. She's a principal cybersecurity engineer, leads the cloud security capability area, and teaches cloud security for the MITRE Institute. In addition to her planning responsibilities, she also has authored a number of MITRE cybersecurity and cloud computing papers. So she's an author. Her topic today is 2019 State of the Federal Cloud Security, a Practitioner's Perspective. Ladies and gentlemen, please welcome to the stage Dr. Spina.
I'm really not going to wear these Google glasses, but they look cool, didn't they? I can't see unless I put on my real glasses. These aren't the Google glasses. Yeah, like they don't have cameras and heads-up display on them. So it's good to see you. I'm glad to be here. Oh, God. Brian and June were the reasons I'm here, and thank you for that, but now I can't get this to stay. Okay, that'd be good. So I do cloud security at MITRE for the MITRE Cyber Tech Center, and I run the cloud security capability area. And so I really do focus on trying to make the world a better place. That's why I work at MITRE. And so I want to bring innovation and change to the commercial cloud capability. When the gentleman who introduced me said I work for the international community, it's really the Intel community. But sometimes they do get international. So I want to make sure that, you understand what people in the field are seeing in the practice of cybersecurity in the cloud. And, it can be very clouded by, some of the vendors, right? Pardon the pun. And, they make it seem all very, very easy. And they say, well, just go ahead and implement this, we give you all the tools, but quite frankly, they don't. And so it's my job, it's our job when we go into the cloud to try to do it right and to make sure we're getting it right. So that's my championship, and I hope that I'm effective with you in this area because government cloud security is really important for me. So I joined the Cloud Security Alliance. Anybody know them? By the way, I'm happy to be very interactive here today. We have more than enough time. I can present this in a half hour, so we have a half hour to talk. And I did that because I wanted to make sure that the government's voice was being seen and heard in the research being done for cloud security in industry. And the Cloud Security Alliance is actually very big in that, and they publish some really good papers. And they have the hallmark Cloud Common Control Index, or matrix, CCM. It's fantastic. Always a good place to look. Sometimes a little bit high level for the things we want to do as engineers, but absolutely very good. So let's go into the message that I'm going to give you today. Let's see, oops. Okay. So these are kind of like, colloquialisms. I want you to kind of take these buzzwords away. But I want you to really understand what's come about really in about the last year, maybe a little bit more. I initially presented this at the Cloud Security Alliance Forum earlier this year, and so there's some new things I'll talk about which may not actually be in the slides, but the slides are public release, which really do give me just a platform to talk about stuff. So from cloud first to cloud smart, what does that mean? Well, it's real. okay? It's not something we're thinking about. But the cloud providers are actually doing a really good job bringing cloud security capabilities. And let me show you some of those. But, you know, quite frankly, we don't have a good cloud vulnerability model. And in fact, the CVE index that MITRE puts out doesn't cover cloud services yet. And oh, by the way, it's time for a cloud-based CVE. Have you seen a single CVE that says in Amazon, these are the things you might see? And then as a result, how do you configure to protect yourself? Becoming threat informed, this is big. This is big. I'm sorry if I say it too many times, but the MITRE attack model is evolved and it's now touching the cloud. The other thing is that people are understanding the gateway. It can be an issue. The tick bottleneck, right? We all know we have other bottlenecks, right? In DoD, we have the cap, which is very, very similar, very, very similar. And so the notion of clearing the trombone, the requirement to come back into your corporate net so that you can go through that back-end connection to the cloud can really be a nuisance. And that's the trombone. And so, but I like to say the Great Cosby, because many of you may understand the Great Cosby or cloud access and security brokers. They are really making a splash, and they're really coming about. Something really important, I believe, for us to look at. And then ATO streamlining. This whole thing about the DevSecOps pipeline, it's changing defense critically. And we're not all getting it. So let's try to get on the same page. In Zero Trust We Trust, that's supposed to be kind of a joke. Because there's not a whole lot to trust about Zero Trust, and let's talk about that too. But more secret clouds on the horizon. I think you should expect those to come, and they're here. Return of the Jedi, of course, right? We heard a fantastic briefing yesterday on Jedi. Let me tell you how I think it's going to help us in the coalition interoperability segment. And then, oh, by the way, don't forget the SCCA. I'll have to brag a little bit, but I built it. And I spec'd it, and I worked with the vendors, and we actually had an implementation, and DISA was going to roll it out as a service, and I think they're still working on that. But quite frankly, cyber in the cloud is a big data issue. And we really only have one area right now of science and technology that's emerging that has any hope of helping us, and it is AI, ML. I know that's been touted a lot. I know these aren't new things for you guys, but let me give you some ideas that fit and help you put it all in perspective. So, cloud first to cloud smart. So we had a recent memo from the White House, I think it was 13800 executive order, and it said basically we're moving it to cloud first. And these are some of the tenets, right? Security, procurement, workforce. Let's streamline those. Let's make them effective. The one that really gets me is the workforce gaps. They're not insignificant, and many of you continue to talk about them. But I mean, for example, just to name a few, the cyber defenders that look at data logs, right, are only just now becoming familiar with cloud service logs, activity logs. And oh, by the way, the perimeter has opened, so most of our defense in the SOC has been network aggregation point focused. We can look at the logs off the routers, off the gateways, and we've become really good at building heuristics and detection algorithms. What is a hunt or a detection algorithm when you're looking at a cloud service activity log? It's really vastly different. They don't map over. Just the mapping from HP ArcSight to oh God, what's the big log tool? No, I forgot, sorry. Splunk, right? Just the way that Splunk does free text search, right, and ArcSight has a data model, it confuses the whole thing. The scripts are all different. And so this is the type of change we're getting in the cloud. And so we have to retool these guys. The other area, just to sort of keep you thinking about it, is now that we're doing pipeline integration and DevSecOps pipelines, we're really asking our developers to understand cyber. Defense actually starts and may in some cases end in the pipeline. So it's no longer effective for the SOC operator to not understand the pipeline or at some point in the near future be able to operate it. So think about the SOC defender looking to do deceptive defense. They're going to have to dig back into the pipeline, right? But things like, and here's the beauty in the cloud, right? Infrastructure as code. I can now remap all IP addresses on the fly. I can deploy honeypots really, really quick. What I really like about interoperability in the cloud is I can deploy whole coalition domains with a push of a script button. So these are the things that we're facing. And you know, the point is, Cloud First says, look, knock down some of those barriers, keep the right people, reward the right people, and hire the right people. And then, of course, it talks about the TIC. And the TIC, we just had recently a new memo that I think I'm trying to remember who it came out of, either OMB or even DHS. And it says, here's some use cases. Unfortunately, they still haven't given us TIC 3.0. But we think it's going to be called TIC 3.0, right? It's not exactly known yet. And we believe it's going to eliminate the trombone. And I'm going to talk to you about how we do that. We're actually kind of already doing that in industry. Technology's got solutions. I know you've seen it. So we're going to look at that. But, and by the way, FedRAMP, CDM is continuous diagnostics and mitigation. Continuous monitoring, right? The old RMF, continuous monitoring. But you know, FedRAMP is not a mandate. It's not a law, right? Federal agencies don't actually have to use FedRAMP. So we want to focus on pushing FedRAMP because it really does help us all to stay on top of things. And you know, FedRAMP is supposed to get regular monthly monitoring data, right? That says, hey, look, we're still effective. We're still doing security right. And then, of course, in terms of procurement, many of us have wrestled with making that easier. I don't claim to be a procurement expert, but recognize it's part of this move and this initiative by the government. Okay, so just take a look at this. If you had to compare what you had on-prem, there's an answer to it in one or many clouds today. It is interesting to note Alibaba, because they also provide security services too, not that you might be using those, but I'm not going to actually go into them. The point is, there's really a lot of tools, but that's the problem. There's a lot of tools. And so, you know, how do we use them? How do we use them right? What is the context? What do we do about the logs, and how do we interpret the logs? And oh, by the way, every cloud provider has a different set of logs. So when you get to a multi-cloud environment, what does your management interface look like? Well, you're going to want to pull your hair out because it's not easy. And there's not a lot of really good tools that make that really simple. Some of the solutions here are to deploy your own cloud, like using Cloudera or OpenShift Container Platform, OCP. And, you know, I can make everything look common and then deploy it to whatever cloud I want, theoretically, by just spinning up virtual machines. But then you lose the beauty and the elegance and the effectiveness of using the cloud provider's special things, special sauce. And you really want to be able to get to those if you want to be, you know, cost-effective and efficient. So, you know, we don't necessarily want a solution that prohibits that. So we're still working on the common management platform. Okay, but what does it mean? What does this shared responsibility model mean? People really aren't, we're struggling. The entire government is struggling with what it means. You can't believe how many situations where I've seen government sponsors and their vendors post machines in the cloud, spin up applications, and essentially forget them. And forget about all the security you got to wrap around and all the security you have to do. And their answer is, well, the cloud provider's doing it. No. The cloud provider is not doing it. We have to do it. Where do we have to do it? We need a model that helps us get it. So, you know, I love to make models. This is kind of what I do. But RMF gave us a tool set: common controls, hybrid controls, and system controls. Common controls are the things you get to trust because you can't see them, you don't get to use them, you don't get to fiddle with them. They're what the cloud service provider was authorized on, right? But the other thing they were authorized on are the services they bring that you do get to configure. Those are the hybrid controls. Now, when you look at in the DoD, and I don't know if there's a coalition-based or MPE-based cybersecurity controls, but DoD loves CNSSI 1253, right? Those don't change. You really still got to focus on those. The only beauty in some of the things that we've done for cloud is give you a guide for how to map common controls and hybrid controls to the CNSSI 1253 when you choose your baseline. RMF didn't go away because you went to the cloud. It may have gotten easier because you have less controls to authorize to, but it didn't go away, so don't forget you still got to do it. But the hybrid controls are things that we do. As you go up the stack, we do less, but that's the area where we're having problems. In fact, if you recall the Capital One breach, there's a little bit of a claim that maybe Amazon hadn't configured their metadata service properly, so maybe they take some culpability. But quite frankly, it's just another case of where the consumer, the Capital One consumer, didn't quite configure their firewall right. They probably shouldn't have allowed a communication path that they did. And they ended up with server-to-server credential forgery, where the hacker logged into an open machine, and then because that machine was trusted by another machine, logged into the other machine. Oops. Sounds like the cuckoo's egg all over again. So let's get this right, right? Let's get this right. System controls are the things you bring. You deploy a virtual machine, you spin it up, you load the OS, you load the applications. If it's a container, same thing. You have to make sure you did that right, right? The whole scanning and patching, that really just didn't go away. Or vulnerability scanning. I don't like the notion of patching. I'm gonna tell you why. So, I pulled in the Cloud Security Alliance at MITRE, and we formed a research group. And the issue was, look, we need to know, will industry support us if we try to implement a CVE structure, Common Vulnerabilities and Exposure Index? Anybody know it or not know it? Have you used it? Please use it. They're fantastic. So right now, every time we find a vulnerability in a software package, right, a completed executable, that's on the market, either open source or proprietary, and we found a vulnerability and we understand the mitigation and we report it. And there's these groups of reporters, people who get to report it, and they're specially assigned and selected and nominated. But we're not doing it for the cloud. I'm going to show you in a minute why we should be. But anyway, this should be coming about shortly. The research is still sort of in process, but generally it's finding out that, yeah, industry wants this. The cloud service providers are willing to support it. They weren't quite happy about it because, you know, it's a little bit of dirty laundry. But they're moving to do what's right, right? But we got to push them and prod them a bit. And the point is they agree that if there's a vulnerability that you can, when you deploy, do some configuring about, configure your thing or deploy something in a certain way to make it more secure, they want to tell us about it. And so that's a positive thing. So look for that. Okay, here's the MITRE attack matrix. Just released it. MITRE had an attack con, like Comic-Con, right? Everything is XY con. And so they recently released this. I hope you can see it. I know it's a little bit light. But these are actual attack vectors that have been demonstrated and confirmed in commercial clouds. Amazon, Google Cloud Platform, Azure, Azure AD, Office 365, and other general SaaS. This is a big deal. Because, and oh, by the way, it's kind of small. I mean, that's almost the whole matrix. Now, if you click on any of the cloud providers, AWS, Google, or Azure, you'll see a whole different, not a whole different set, you'll see specifics of those. The actual ones that were verified and validated to having actually occurred in those clouds. Very powerful. Now, what's interesting is you click on any of these and it gives a full description of it, a full example set of when and how they've seen it, a ton of references and research that you can go follow. And oh, by the way, the link is at the bottom. If you can get my slides, that link is hot. But it also gives, in that cloud service, how would you see it? What logs would you be using to see it? This to me is, you know, I've been praying for this for a long, long time. So we got this. And there's no reason now that you can't be threat informed. And again, these are threat. Now, if you look at the top, right, it's the cyber kill chain, just broken down into greater granularity, right? But initial access, now I'm having a problem reading it. Can you read that next one? Persistence, privilege escalation, defense, evasion, right? Anyway, hard for me to read. You probably can't read it as easy. Yep. So anyway, a good thing and an awesome tool. So I'd like you to go drill down. Let's talk about TIC 3.0. And what I'd like to sort of draw your attention to is this notion of trust zones. Can you feel zero trust creeping in? That's really what's happening. Zero trust is creeping in. But there's no reason that, you know, coalition segment can't be a trust zone kind of thing. And so the technologies and solutions that they come up with will probably apply well to what we want to do in a coalition. But what you're going to see probably is a lot of zero trust type answers. And so, but generally speaking, what we see is the TIC 3.0 defenses, which could be applied to IAP or cloud access point, is a distribution of the defenses broadly. A distribution of the defenses to as close as the application. And this is not new for industry. Industry's been selling us the gateway proxy hosted at the application for years. It's really not new. I built the cloud security, the secure cloud computing architecture the same way. So this is what you're going to see when it finally comes out. I can't say it for sure, but this is where I think they're going. Cosby. Anybody use a Cosby? Cloud Access and Security Broker? So there's probably going to be a next near-term merger in the industry. You're probably going to see Cosby providers and zero trust providers merge. M&A, big time. Because they're realizing that if I can do zero trust access, then the Cosby, really what the market that the Cosby grew up in was you had consumers deploying things into the cloud and they didn't understand, one, how to monitor their stuff, and two, how to read their logs, and three, how to make the logs into detection algorithms. The Cosby folks are doing that. The Blue Coats, the Cisco SOC tool, or Cloud SOC. So you have a number of big players that are in there solving that issue. And so the Cosby sort of grew up to be the intermediary between the cloud segment and particularly the log APIs that were coming off the cloud. And so it deploys in two ways. One is to be a proxy, right, goes in the way of the traffic. The traffic still aggregates through it, and that's a lot like the tick and the cap. People really don't like that. But the other assumption is that maybe I can just look at logs as near real time. And if I'm looking at logs as near real time, do I need to be in the way of the traffic? Do I need to be in band? Do I actually need to monitor the full packet capture? Do I even need the full packet capture? There's a number of folks trying to solve the question of, well, let me do full packet capture at the endpoint. And just at the endpoint, not at the gateways. Because it's all unencrypted at the endpoint. But now what's the problem? I've got this huge distributed data set of feeding logs, bombarding me and making it even more difficult to handle the log sets. It's a good attempt. It'll probably work, but we're going to need some streaming data, AI, ML, big data science to help us. But what's nice about these is again, anything you put in the proxy, like data loss prevention, IDS, IPS, all that works really, really well if you use it. And then when it comes to the out of band, well, you hope that they got the log analysis correct. But let's talk about this pipeline. And what we're talking about is that we really do have a situation today where infrastructure as code is real. And we can do it in just about any cloud. And it's a simple scripting program away. But defense, what we're realizing is defense is in the cloud. In the pipeline. And so you got to get these pipelines right so that the code and the solution you deliver and you post is secure. But the other thing is it can be spun up very quickly. These pipelines can be invoked very quickly, and you can deploy new environments, especially once you have a good template. Once I have a good template and I have a new, potentially, say, an emergency or disaster relief issue, something very quick comes up and I have to go quickly respond, this is the kind of place where I'm going to go and I'm going to deploy the template and set up the environment. You got to ATO these pipelines. Even before you post any code, you got to ATO them, right? Look at all those controls. Look at it just like a system. And make sure you go through that cybersecurity analysis. But once you do it once, theoretically, you shouldn't have to do it a whole bunch of times. The other thing is that it may depend on, when you get that ATO, the environment you're going to. I call it the beachhead, where you're landing. When you land on that beachhead, that's going to affect how the pipeline codes itself, how things are built because of where they're going to land, and how things are monitored. But if I show you a pipeline, I can show you where I want the SOC to interact, where the developers have to know cyber, right, and how to authorize that solution. And these are like new skill sets. But don't forget them just because they're not here. So one of the problems that I see big time is sponsors are leaving their DevOps environments open in the cloud with open internet gateways. Why? Well, that's how the developers did it in the past. But in the past, the developers were stuck behind a security stack inside a data center. Nothing could get to them. They were actually secure. Well, that's what they're still doing. They still think it's okay. So when you build that pipeline, build it behind your security stack. Build it in an enclave that's protected. DISA has a guide on A, B, C, and D network types. Look at that and build it like that. So don't forget to protect that environment. The problem with leaving that environment open, and some people don't realize, is that the attacker can easily profile your servers. Once they get copies of it and they figure out what you're running and what's on it, they can go hack against it when you don't know it. They just make a copy. And now they've essentially built an exploit. Then all they got to do is get to your real system and they got you. So this is new and this is hard. And we're asking people to do a lot of different tasks that they're not used to doing. And every time we do this in cyber, stuff falls between the cracks. And we have cybersecurity issues and their vulnerabilities. And they can be organizational because the developers didn't know that they had to do cyber. And oh, by the way, the SOC's not monitoring because it's a development environment. A big gap. Try not to let it happen, please. But I assume it will for a while. This idea about InSpec and the dashboard is all about, and this is a new sort of contextual scripting language that helps you embed test keys to kick off automated testing in a set of code or scripts that you write. And the idea is if I have built some new code and I embed these keywords, the syntax, then I can do this automated testing and have a dashboard that runs. I can have a dashboard that runs continuously depending on what's in the pipeline at any time. I think that dashboard should be extended to ops, and you should be able to inform the beginning of the pipeline with the threat environment, right? So the SOC folks should be informing the developers on what they see in terms of the threat environment. And that's one of those ideas, you know, when I say let's be threat informed, we have a common lexicon. The MITRE attack model gives us one. The NSA threat framework 1.0, 2.0 gives us one as well. Those are good lexicons. Okay, so what's wrong with zero trust? So zero trust is a good thing. It's a much better thing than we've had so far. But it's really just trying to get us to attribute-based access or role-based access. Boy, it's taken us a long time. We're still talking about it. Who knows if it's ABC or role-based, right? Which one are we doing? I struggle with it too. It changes, right? So it's going to help us with that. And what it's doing right now is about the best it's able to do is help us understand context of someone trying to access. And by context, we typically mean things like, is their device managed? Do I know the device? And what IP address are they coming from? Okay, that's good. That's not the best. Banking industry has been doing it a long time to detect fraud. So it's not that new. Now, DoD is only recently doing it. And we're all going to get better at it when zero trust vendors are able to bring us what we need. But unfortunately, most of the solutions we see today, in fact, almost all of them, aside from possibly, well, I would say look at Google's Beyond Corp. I know it's the hallmark, but look at what they do in terms of behavioral analytics. So the problem we have today is they're still identity-based. It's still a CAC card and a credential, a code, a password away from being hacked. Credentials get bought all the time. They get stolen all the time. Social engineering gets codes out of people. It just happens. Credentials are, you know, identity credentials aren't the end-all to doing zero trust correctly. But once we start understanding human behavioral signatures, I can tell you if that identity is going rogue or acting abnormally. That's what I want to know. Because, you know, any identity, any person can get upset and become an insider threat, and then credentials can get stolen. And so the only way I'm going to know is by looking at behavior. We're not doing behavior analytics yet. We say we are in some cases, but we really aren't. So look for that. I think when those come about, we're going to get some real, true zero trust solutions. But the other big problem here is privacy. So if you look at something that Google is going to try to push, and they're struggling with it, and you can see it hasn't come out yet. We just talked to them last week at MITRE. But Google sees on the internet, Google sees just about where you all surf. Just about all their surf, especially if you use their Google web server, browser, they see everywhere you go. So they actually know your surfing behavior. Imagine if surfing behavior had anything to do with how clean your computer was, how well maintained, what kind of hygiene your computer was in. You might reason that they see downloads, you know, they see the bad software that you're getting, and they see where you go. And maybe there's a determination. But is that a privacy issue? So now, it'll probably be a privacy issue. The privacy folks will say it will be. So they're going to ask you if you opt in. At some point, zero trust will require us to opt in. When we go on a DoD network, we opt in all the time. We get the big banner and it says, oh, by the way, I'm monitoring you. Pretty soon it's going to say, do you mind if Google monitors you because they help us and, you know, we use that data. So think about that world. Now inside the private network, it might be easier, right? Less privacy issues, but still some. Anyway, this is the MITRE model for, that was the MITRE model for what things we want to make sure you're looking for when you, and the behavior analytics is way down on the bottom. But those are the things, these are the things we want you to be looking for. It's not the most elegant model, but unfortunately when we look at zero trust, there's gateway proxies, there's perimeter proxies, there's not a whole lot of proxies, there's federation, and there's token services, smart tokens, SAML tokens, OAuth tokens. So it gets hard to architect if you wanted to come up with a single solution. But who's familiar with SCCA? Who's broken their teeth on it? It's really still an effective solution. I guarantee it. And the reason I say that is, one, it puts a security stack in front of your apps. This is very much akin to a zero trust security stack. It can use a token to allow access. It can also break and inspect, right? There are issues with keys and where you put the credentials in the keys so that you can break and inspect. And there's some impersonating going on, right? You may have to make that proxy that goes in the virtual data center security stack, you may have to make it the front end of the application. But this is no wonder F5 started out as a load balancing organization, is now doing IDS, IPS, and oh, by the way, access proxy zero trust stuff, all in one F5 box. It's this solution. It's this kind of solution that they're going to. Because we still want to break and inspect. We want to break and inspect because we know how to understand the heuristics and the threat algorithms at a gateway. We can do that. We know how to interpret full packet capture. It took us a long time, but we finally got it right, probably 40 years. We finally got it. We're getting there, right? And we can actually be good at it if we set our mind to it. So it's really hard to rip that away from the cyber defender. Don't take the cyber defender's eyes away. Keep them, give them the right visibility. The Cosby we like to call a visibility platform. If you look at the DoD CIO's cybersecurity framework or model, reference model, they call it the visibility platform as well. So don't take the visibility platform away if you don't, if you can keep it. But if you can't, then let's learn how to understand the visibility that the service logs are giving us from the cloud. And then, of course, the management domain, you're always going to want these general support services up in the cloud. Although I contend that the reason we built it this way was because we still had STIG requirements and, we still had scanning and patching and continuous monitoring requirements that didn't really understand, when we came up with this, didn't understand the DevSecOps pipeline. So if that's more or less the DevSecOps pipeline, that even works too, okay? So there's a lot that can go into that management domain, the virtual data center management solution. But what it does, and many of you may not like it, but it does make the cloud look like a DoD data center. A core data center, if you know, what is the, anyway. Where did the core data center concept come from? It was the EI, anyway, I forgot it, sorry. But anyway, so it does. Now there's one important thing that we're all still struggling with, and that's the notion of PAM, Privileged Access Management. And that's why the thing on the top, TCCM, Trusted Credential Control Manager. And that's the person that takes those cloud credentials, multi-factorizes them, and that's the provisioning portal, and then locks them away in a safe, one of the factors. The hardware token factor, lock it away so that no one really can use it unless you have a break glass situation. And then, more importantly, before you lock it away, make sure you've assigned role-based credentials to other folks so they can get in and manage things. And oh, by the way, don't have any one administrator that can do everything. Have one administrator that maybe can post new code, one administrator that can configure networks, right? And so split those responsibilities up so you don't have a single person with super user power. Right. Oh, another thing I wanted to talk about based on the pipeline. So this is where I say scanning and patching isn't relevant anymore when you have a DevSecOps pipeline driving infrastructure as code solutions. It's really not relevant. I don't scan a production server and then take it offline and patch it. I deploy from the pipeline a clean, well-intended solution. I'm not scanning in the pipeline. I'm sorry, I'm not scanning in production. I should be scanning in production, in the pipeline maybe, right? If that's how you want to do it. But if you have secure code repositories, if you're getting your code from the right places, if you understand the hashes and the signing of it, and you can trust the code, right, maybe you don't need to do a whole lot of scanning. And so that would be one way that the pipeline can help you. If you have this trusted code repository, just reuse it, if you can reuse it, and it works. But then the other thing is, right, since I really don't, if you look at what the pipeline does, it really takes the need for the administrator in production out of the equation. Imagine what your insider threat surface looks like when there's no administrators in production. No administrators in production. Yeah, I almost have to repeat it just so people get it. Because if the only people in production are users, the minute you see an escalated privilege, you've got to be on it. Because you're not supposed to have an administrator in there. There's no super users. You don't need them there. Once they post the system and it hosts and it's running, get them out. If you need to add users or do a simple configuration change, do it in the pipeline and plan the deployment. The other thing you get with the pipeline, and I didn't mention it on the DevSecOps, is non-persistence. Non-persistence is extreme in reducing the threat surface. Imagine every time an attacker takes hold of a machine or a host, and a couple hours later you just wipe it away and deploy a clean one. They got to go through all that all over again. So the more frequently you can deploy your system, the better off you are. The more non-persistent you can be, the better off you are. Knock them off the network, knock them out of the system, because it's non-persistent. So get in the habit of building it in the pipeline and deploying fresh and clean on a regular basis, and stop that scanning and patching in production. And get the administrator out of production. There's no reason you can't do it. NBIS, I don't know if you know about NBIS, it's that background investigation thing that DIS is working on. That's their solution. No administrators in production. And that was something we were pushing at MITRE for a bit. So it works. It can be done. Again, stop me if you have any questions, but I'm happy to field after. So the secret clouds are here. I suspect this is one of the reasons Microsoft won the Jedi, is that they are here. I really don't know much about the procurement, but this is a really good note, right? This is a really good note. I think Oracle's working on a classified as well. So I think you can bank that the cloud service providers recognize there's industry there, recognize there's value, and they're gonna move into it. I can tell you, if you try to connect to SC2S, it can be a headache, simply because the current connections through the DoD going into DISA are for the Intel community, which is a different title of money kind of thing, and so DoD's not supposed to use those links. Now, maybe there have been exceptions. If you have an Intel community connection, maybe you can rationalize, you can use it. But you end up having to deploy your own connections from the back end of your data center to get on the NIPR or the SIPR to get to C2S, SC2S, secret C2S, which is Amazon. And it looks to me, when I look across what is Azure trying to deploy, it's the right stuff. The Azure Security Center is really good. It's really good. You'll be impressed at all the things it does to you. It does the threat detection. There's no organization that knows the Microsoft threat vector, threat signatures better than Microsoft. and they've already built the network intrusion detection heuristics and algorithms. In their cloud, they run it, and they tell you, based on what they see on the network, we think this is happening. Amazon won't tell you that quite yet. They do have Inspector and other tools that you can get to work at some point in the future to help you do that, but Azure gives it right out of the box, which is good. And then high performance computing and AI tools, they realize we have a big data issue, and they're helping us. So this is a positive thing. But Jedi, and you're thinking, well, what more can I say? Well, from an interoperability and coalition forces construct, it's going to give us cross-domain solutions that we probably haven't seen before, and that have been woefully lacking. This is where I see a lot of value. They're going to be able to spin up a little quicker. They're going to move a little quicker, be more agile, be more prevalent. I don't know if they talked about it in the last briefing yesterday on Jedi, but to me, this is positive. And when I see this notion of fit for purpose, you should be thinking, well, I'm going to have an expedition that goes out. It's going to be coalition-based. I'm going to use my DevSecOps pipeline. I'm going to spin up a special enclave, solution set, application suite, security suite, zero trust domain, and I'm going to do it quickly. And I'm going to do it in Jedi. That is really powerful for us. We haven't had that ability. You've been trying to get data out of the back end of core data centers that it's not marked, it's not tagged, doesn't say which coalition can have it, which partner can have it. So look to this to help us here. I'm very fond of this. And then finally, why do I say AI ML to the rescue? And I know everybody else has been thinking that. Some of you have been thinking, yeah, really? Come on, this can't be. So here's why I say this. First, there's a plethora of AI ML platforms out there in Azure, Amazon, Oracle, IBM. IBM's got a really good one with, shoot, God, I keep forgetting it. Yeah, he used to play chess. And so the point is the tools, the SciPy, right, the Python programming for science platforms, those kinds of things, are all in the cloud now, all easy to access. And developers, in an open sense, are contributing their own scripts and their own code that's reusable, right? Be careful when you use anything open source, because you got to trust it, which means you might have to rescan it and, debug it yourself. But because of this, we're going to see a growth in algorithms that are reusable and contributed to the community that we can reuse. So, for example, just consider in cyber, the algorithms that Amazon and eBay and any of the great retail outlets use to determine what you want to buy next. It's really not hard. It looks at what kinds of things do you do, what kind of things do people like you buy, who are your friends. This is where Facebook comes in. Who are your friends? What are they thinking? And makes a probability determination on what you might be buying next, and oh, by the way, happens to show you. There's no reason we can't use that very same algorithm to predict where you're going to surf next. And oh, by the way, when you don't surf there next, it might be abnormal, right? So don't think that these tools and these algorithms that are out there already that the rest of industry, that other industries are using can't be used, because they can. They may have to be modified. Microsoft recently said, look, we've solved 80% of all AI ML use cases. We already have tools for you. You can plug and play, just grab our script. Just insert it in your code, and you'll be able to do it. That's a big thing to say. We also know they've done some studies that say, well, Microsoft runs this on our network, and oh, by the way, if your network's a little bit smaller or a little bit bigger, they're still similar tools. The algorithms work well, you just got to tune them. So wouldn't it be nice if all we're doing is grabbing, plugging and playing these algorithms and then just tuning them to our environment? This is where we're going. This will be possible. It's possible now. We just need to get comfortable with it. Unfortunately, today's data scientist is spending, I can't remember the statistic, but it's an inordinate amount of time finding data, cleaning the data, tagging the data, categorizing the data, putting it in some form that can be used by the algorithm. I think it's like 80-20, 20% building the algorithm. You don't get good algorithms at that point. And 80% of the time trying to find the data, the right data. So you just, I mean, these poor data scientists, we actually do teach data science in academia, and we teach it well. What we don't teach them is when they go into the government, they're going to spend most of their time making deals and brokering requests for data sets and getting access to data. So we hamstring them. And then we ask them why they're not giving us good algorithms. Someone mentioned in the last talk the chief data officer. Hear, hear. Hear, hear. Right on. That's exactly what we need. So, all right, so then to sort of recap, right, government is focused on making cloud work. I think we can make cloud work. Industry is actually making strides to give us more and better tools. Let's figure out how to use them. I know it can look like a daunting task, but it's positive. The shared service model continues to perplex us, and where it perplexes us is where we get the vulnerabilities. I can give you one tidbit here. If you ever want to operate in a cloud and you want to know your responsibility as a consumer, go get the cloud service provider's FedRAMP authorization package, and it'll show you the customer responsibility matrix. And it'll say for every single control, this is what you have to do. It's not exactly that easy to read, but it's a really good start for your cyber team. CVEs, we're going to get them in cloud. It's just a matter of time. We're on the cusp. We now have a threat matrix for cloud services, commercial cloud systems. Use it. And go to that MITRE website. It's free and open. It's there for you to do that. Even before you build a system, look at that threat environment and say, okay, what would I do to defend against this? Okay, I'll have that tool implemented. It's really not that hard. Look at the Cosbys. Look at where they go with Zero Trust, because they're here and they're growing. And then don't forget to ATO that pipeline, just like any system, and put it behind a security gateway, some security stack so it doesn't get hacked and the attacker doesn't profile your system. But when you look at Zero Trust, consider if it's just identity-based, it's probably not the end game. When you start getting behavioral analytics in there that work to develop signatures for what people are doing, to help you understand if it's really them or if it's a rogue them or if it's not them, because the credential is just insufficient. And then look at SCCA. It's not there's a document on the DISA website. I think it's on the DISA Cloud Security page. It's actually really good. It's simple to read. And thank God for Jedi. We're going to get some good stuff. I'm very positive on that. Classified clouds will probably get some more. And let's start using the big data analytic tools, because this is the only way that we're going to get anywhere close to the holy grail that we think big data is going to bring us. But also recognize big data science is being taught in academia today. Sometimes it's called data science programs, and they teach a cloud computing course. I did that a couple times. And sometimes they call it big data. So keep that in mind. And with that, that's the end of my talk. And I am happy to answer any questions and work with you on whatever might be ailing you at the moment. Anybody got a pain point? Oh, did I take that much time? Oh, wow. Oh, my goodness. Okay. Yeah, come on, guys. Oh, 5 minutes left. Look at that. Did you just type that in? Hello?
So I don't know if you could comment. My name is Eric Thompson. I'm from
Hi, Eric.
A7 Technology, and one of the major areas of concern that I have in terms of deployments has to do with the networks and the ability to get the proper speed to take advantage, and especially when you talk about secure cloud, like I'm not seeing enough done in terms of sorting out how do I get to that cloud securely from wherever I am. There's just not enough pipe there. There's a lack in that area. Can you comment on that a little bit?
Yeah, so in cloud access, there's two cyber aspects that we're concerned about. One is protecting the desktop or endpoint that you're trying to access with, and the other is protecting the application and environment that you put in the cloud. In some cases, those can be two different organizations, right? People can come from one organization and log into another organization's application. And so DoD does this with a CAP and a VDSS. The VDSS protects the application in the cloud, and the CAP protects the DoDN or the DISN. And so you see the notion of two separate devices. An interesting solution coming out of Zscaler, which is actually FedRAMP authorized, but not DoD impact level authorized yet. Although, I'm sorry, but if they have a FedRAMP authorization, they should be impact level 2 authorized. 4 at the moment? Oh, good. Are you from Zscaler? Is that just recent? Thank you. Wow. Boy, I'm impressed. So Zscaler has a really interesting solution that they can essentially put, for all intents and purposes, cloud access points and virtual data center security stacks, like I showed in the SCCA, widely distributed, as closely distributed to where you want, either your user or your application. And they can give you many. Remember I said the tick was going to distribute? So imagine I think the tick has something like 28 or 30 actual security controls it has to meet. Imagine distributing those to various points in your network. And so that's the solution that I think is a good place to look, because you have those two places to protect, the app and the user platform. Now that may become a little bit different when we have bring your own device. Maybe we start not caring about the user device as much at some point. But you know, if the end device doesn't have good hygiene, then they're a risk. They become an insider issue. So yeah, that's all I could say is distribute it. Now I don't see DoD or DISA solving the CAP bottleneck other than just more bandwidth. So I know we've had routing problems a little bit there. We've had to go around things. Skype likes to not work through a CAP, stuff like that, for Office 365. I know there's been issues. I don't know what all the answers have been, but you know, those are some of the forums we're using to solve it. What do you think? Any other questions? Just one? Oh, he got up and then walked away. Okay. Yay. That's okay. Thank you. Appreciate you listening.